Hello everyone, I am Akash. Before getting started with the course, quickly take the pre-test.
आ रहे हैं
Hello everyone, welcome to the second module of e-learning course on power system protection. In the previous module, apart from discussing the nature of faults, types of faults, qualities and basic principles of protection, we have also discussed about the components of protection till tripping and auxiliary supplies. There is one more component and a very important one, which is relays. We will discuss about it in detail in this module. Let's get started. Let us take a look at the objectives of this module. By the end of this module, you will be able to define relay, explain the function of protective relay, explain the operation of protective relay, classify and discuss each type of relay, namely electromagnetic relay, electromagnetic induction relay, electrothermal relay, piezoelectric relay or gas-operated relay, static relay, digital relay, and numerical relay. Let us get started with the first topic. Let us begin by understanding what is a relay. Relay is an electrical device which senses the abnormal conditions in a part of power system and gives an alarm or isolates that faulty part from the healthy system. So what does a relay do? Well, the function of a protective relay is to give an alarm or trip the circuit breaker so that it disconnects a component during an abnormal condition in the component, which includes overload, under voltage temperature rise. Disconnect the abnormally operating part so that it prevents the subsequent faults. Disconnect the faulty part so that it minimizes the damage to the faulty part. Now, how does a protective relay operate? When any abnormal condition develops, the main function of a protective relay is to sense the fault and isolate the faulty section with the least interruption to the service by controlling or operating the circuit breaker. So, how does the relay sense the fault? Let us understand with the help of this diagram. This is a small part of a power network circuit of a plant. It is designed to protect the load side equipment by allowing a certain amount of current. The current transformer CT senses the load current continuously. The relay is designed and programmed to detect the abnormal condition and generate the trip contact. Therefore, in response, the plunger of the relay coil goes down, sending the power from the battery to the trip coil. The trip coil acts as a magnet and pulls open the switch. This disconnects the faulty current flow. Two categories of relay are most commonly used in protective relay. They are secondary indirect acting relays that include current, voltage, power, impedance, reactance, and frequency. Secondary directing acting relay, which is a group of overcurrent and under voltage relays designed to operate immediately or with time lag. Let us now discuss about the classification of protection relays. Protection relays have evolved over time and have undergone many changes. They are classified into 7 types. They are listed on your screen, starting from the oldest, electromagnetic relay, to the latest one, numerical relay. We will discuss each of them in detail further. Let us begin with electromagnetic relay. Click on each type of relay in sequence as you proceed. An electromagnetic relay can be of the following types: plunger, hinged armature, balanced beam, and moving iron polarized relay. These are simplified types which respond to AC as well as DC. We have learned that the simplified types of electromagnetic relays respond to AC and DC as well. Let us see how. In DC, the electromagnetic force exerted on an electromagnetic relay can be of the following types: plunger, hinged armature, balanced beam, and moving iron polarized relay. These are simplified types. Let us now discuss about the classification of protection relays. Protection relays have evolved over time and have undergone many changes. They are classified into 7 types. They are listed on your screen, starting from the oldest, electromagnetic relay, to the latest one, numerical relay. We will discuss each of them in detail further. Let us begin with electromagnetic relay. Click on each type of relay in sequence as you proceed. An electromagnetic relay can be of the following types: plunger, hinged armature, balanced beam, and moving iron polarized relay. These are simplified types which respond to AC as well as DC. We have learned that the simplified types of electromagnetic relay respond to AC and DC as well. Let us see how. In DC, the electromagnetic force exerted on the moving element is proportional to the square of the flux or square of the current. In DC electromagnetic relay, this force is constant. If this force exceeds the restraining force, the relay operates. However, in AC electromagnetic relays, the electromagnetic force is given by this formula. This indicates that the electromagnetic force consists of 2 components, one constant independent of time and another dependent on time and pulsating at double the frequency of the applied alternating quantities. Let us now look at how frequency works in an electromagnetic relay. Take a look at this graph. The total electromagnetic force pulsates at double the frequency. The force is plotted graphically, which shows the Fe is equal to 0 in every half period. If Fr is produced with the help of a spring, then it is constant. Then the relay armature will be picked up at T1 and the armature drops off at T2. Hence, the armature vibrates at double the frequency. This causes the relay to hum and produce noise, and it is also a source of damage to relay contacts. This leads to sparking and unreliable operation of the relay operating circuit contacts due to make and break of the circuits. To overcome these difficulties in AC electromagnetic relay, the flux that produces electromagnetic force is divided into two fluxes among simultaneously but differing in time phase. This is done so that the resultant electromagnetic force is always positive, and this is always greater than the restraining force so that the armature will not vibrate. This is achieved through shaded pole or by providing two windings having a phase shift. Next type of relay is the electromagnetic induction relay. An induction relay essentially consists of aluminium disc placed in two alternating magnetic flux of same frequency but displayed in time and space. The torque is produced in the disc by the interactions of one of the magnetic field with the currents induced in the disc by the other. Induction relays are widely used for protective relaying involving AC quantities. High, low, and adjustable speeds are possible, and the various shapes of time or operating curve can be obtained. The electromagnetic induction relay is divided into three types based on its structure. They are shaded pole, wattmeter or double pole winding structure, and induction cup structure. Click on each tab to learn more. It consists of pivoted aluminium disc free to rotate in the air gap of an electromagnet. One half is surrounded by copper band known as shaded ring. The alternating flux in the shaded portion of the poles will lag behind the flux in the unshaded portion by an angle alpha due to the reaction of the current induced in the ring. These two AC fluxes differing in phase will produce the necessary torque to rotate the disc. In the wattmeter type, these are two magnetic systems. A phase displacement between the fluxes is obtained either by having different inductance and resistance for the two circuits or energizing these from two different sources whose outputs are relatively displaced in phase as shown. The rotating field is produced by two pairs of coils wound on 4 poles. The rotating field induced current in the cup provides the necessary driving torque. If Phi1 and Phi2 represent the fluxes produced by the respective pair of poles, then the torque produced is proportional to Phi1 into Phi2 sine alpha. That is, T is proportional to Phi1 into Phi2 sine alpha. The design of protective relay is normally divided into the following stages: selection of the operating characteristics, selection of proper construction, design of the contact movement from the point of view of utmost reliability. The relay operating characteristic must watch with abnormal operating characteristics of the system. That is, it should clearly show the conditions for tripping under various abnormal operating conditions. The most important considerations in the design for construction are reliability, simplicity of construction, circuitry. Contacts. Contact performance is probably the most important item affecting reliability of the relay. Corrosion or dust deposit can cause non-operation of relay. Thus, material and shape of relay are of considerable importance. A good contact system design provides restricted contact resistance, reduced contact wear. The contact material used are gold alloy, platinum, palladium, and silver. The selection of the contact material depends on a number of factors like the voltage per contact rate, the current to break, the type of atmospheric solution under which the contacts operate. Let us now look at the next type of relay, which is electrothermal relay. Electrothermal relay or thermal motor protection relays contain three bimetal strips together with a trip mechanism in a housing made of insulating material. The bimetal strips are heated by the motor current, causing them to bend and activating the trip mechanism after a certain travel, which depends on the current setting of the relay. The release mechanism actuates an auxiliary switch that breaks the coil circuit for the motor contractor. A switching position indicator signals the condition trip. You can also see a compensation bimetal strip in the diagram. The next type of relay is the psychoelectric relay or gas-operated relay, which is also referred to as Buchholz relay. It is a gas-actuated relay which is used for protection of oil-filled transformers or reactors fitted with conservators against low oil level and internal faults. The Buchholz relay is provided with two hinged floats or buckets which on tilting operate mercury switches inside the oil-tight enclosure. Mercury switches in turn actuated alarm and trip circuits depending upon nature of fault. Buchholz relay identifies and offers protection for three types of faults, namely accumulation of gas, oil leakage, and severe winding faults. Let us look at the parts of Buchholz relay further in detail. Let us take a look at the cross-sectional image of Buchholz relay. As you can see in the Buchholz relay, two pairs of electrically separate self-reset make contact, one for alarm and one for trip, provided by mercury switch. They are wired to terminal box. The working parts are housed in a chamber with oil sight window. There is a pet cock provided at the top of the relay. These pet cogs are used for releasing all the air trapped in the transformer or the relay. It can also be used for taking out gas samples. Let us now look at the installation of buckles relay. As you can see here, the buckles relay is connected in the pipe connection between the transformer and conservator, so that normally it is completed filled with oil and the arrow marked on the relay is pointing towards the conservator. The operation of the surge bucket or flow bucket or flow is caused by the flow of oil to relay. Therefore, it is given as upward slope varying between 3 and 7 degrees from the horizontal. A flat surface is provided on the top of the buckles relay case for the purpose of testing and inclination of the relay in pipe connection. Let us now look at the next classification, that is static relay. In electrical systems, a static relay is a type of relay, an electrically operated switch that has no moving parts. Static relays have been designed to perform similar functions with the use of electronic circuit control as an electromechanical relay performs with the use of moving parts or elements. Static relays may be based on analog solid-state circuits. Some authors use the term static relay to refer only to solid-state relays. Let us now look at the next classification, that is digital relay. In digital relay, microcontrollers and digital ICs are used in replacement of analog circuit used in static relays to implement relay functions. By the mid-1990s, the solid-state and electromechanical relay had been mostly replaced by digital relay in new construction. Additional functionality compared to that provided by an electromechanical or static relay is usually available, typically taking the form of a wider range of settings and greater accuracy. Now that we know what is digital relay, let us take a look at the components of digital relay. Basically, digital relay comprises of analog input subsystem, digital input subsystem, digital output subsystem, a microcontroller along with RAM, main memory, historical data file, and power supply. Let us now take a look at the advantages of digital relay. It has high level of functionality integration, additional monitoring functions, functional flexibility. It works under a wide range of temperatures. It has more complex function, self-checking and self-adaptability. It is able to communicate with other devices, less sensitive to temperature, aging, etc. Economical because can be produced in volumes. More accurate. In digital relay, plain for distance relaying is possible. Signal storage is possible.
फिर यहाँ से पानी देंगे पैन से तो सुनता है
We have come to the last type of relays, which is numerical relay. Let us now understand a bit about it. The distinction between digital and numerical relays is particular to protection. Numerical relays are natural developments of digital relays due to advances in technology. They use one or more digital signal processors, or DSP, optimized for real-time signal processing, running the mathematical algorithms for the protection functions. The continuing reduction in the cost and size of microprocessors, memory, and I/O circuitry leads to a single item of hardware for a range of functions. For faster real-time processing and more detailed analysis of waveforms, several DSPs can be run in parallel. In the further screens, we will know about the architecture and advantages of numerical relay. The typical architecture of a numerical relay is shown here. It consists of one or more digital signal processors, some memory, digital and analog input or output, I/O, and a power supply, where multiple processors are used. One of them is the general controller of the I/O, human-machine interface or HMI, and any associated logic, while the others are dedicated to the protection relay algorithms. The typical architecture of a numerical relay is shown here. Several setting groups, communications built in like serial, Ethernet, teleprotection, etc. Power system measurements available, disturbance recorder. CB monitoring means the state of CB and its condition, and backup protection functions inbuilt. Wider range of parameter adjustment, internal fault diagnosis, distance to fault locator, auxiliary protection functions like broken conductor, negative sequence, etc. User definable logic, consistency of operation times, reduced grading margin. We have come to the end of the second module of Power Systems Protection Module 2. Here is a quick recap of the key points discussed in this module. In this module, we have learned that relay is an electrical device which senses the abnormal conditions in a part of power system and gives an alarm or isolates that faulty part from the healthy system. Two categories of relay are most commonly used in protective relay: secondary indirect acting relays and secondary directing acting relay. Protection relays are classified into 7 types: electromagnetic relay, electromagnetic induction relay, electrothermal relay, piezoelectric relay or gas-operated relay, static relay, digital relay, and numerical relay. An electromagnetic relay can be plunger, hinged armature, balanced beam, and moving iron polarized relay. An induction relay essentially consists of aluminium disc placed in two alternating magnetic flux of same frequency but displayed in time and space. The electromagnetic induction relay is divided into 3 types: shaded pole, wattmeter or double pole winding structure, and induction cup structure. The construction of relay is divided into contact, bearing, electromechanical design, termination, and housing. Electrothermal relay or thermal motor protection relays contain 3 bimetal strips together with a grip mechanism in a housing made of insulating material. Buchholz relay is a gas-actuated relay which is used for protection of oil-filled transformers or reactors fitted with conservators against low oil level and internal faults. In electric systems, a static relay is a type of relay, an electrically operated switch that has no moving parts. In digital relay, microcontrollers and digital ICs are used in replacement of analog circuits used in static relays to implement relay functions. Numerical relays are natural developments of digital relays due to advances in technology. We have learned about the advantages of digital relay and numerical relay. Thank you for your time. Hope you enjoyed learning. Click next to take the post test.